Okay, so let's take a look at now at the block diagrams versus bond graphs for the mechanical systems, and the R element is what we have in mind today. So on this side, I am going to put, this is the block diagrams in here, okay? And on this side, I'm gonna say these are my bond graph models. Okay, so let's propose the mechanical system. Let's see, we usually draw it like this. And in here, this is what we do. Okay, so this is the R element in here. Let's just draw what the forces are in here, you know, like this F, and this one down here, F in here. So what does F look like? F is equal to the value of B, which is the constant, multiplied by the velocity like this, right? This is how it works. So in this particular case, you can say that this is your input. We also call it def would be the output. Okay. I called it the action, right? Or this would be the reaction. Or you could call this is the cause, and this is the effect. Okay, all these things. I am doing this deliberately because if you have an input and you have an output, then it follows that the block diagram gets built from the input here. You multiply this input by the value of B like this, and you get the output F. So this block diagram that you see here, this block diagram represents this equation, right? So that is a direct relationship exists between a block diagram and an equation. So in here, I say, well, what about, I say, okay, let's draw a line over here, and now I'm going to do something different. I say, you know, I would like the equation to be written in a little different way. I am going to write it that x dot is equal to 1 over b times f. So now we have reversed the roles. F becomes the input or the cause, and x dot becomes the output or the effect. And if this is true, then I can say if the input is F like this, and then I put this through a value of 1 over b, this becomes the output, which is x dot. So we have this equation corresponds to this block diagram, and we have this equation corresponds to this block diagram. Okay, on this right hand side, I come in and I said, okay, this is my R element in here, and the R element is going to be like this. And I am going to say, okay, I'm going to use a symbol that looks like it has two lines, one horizontal line and this crossbar. In this, I am going to represent the output, and this is going to be my input. How do I determine that? I just was saying the analogies, just see if you can hold this with your hand. There is your hand. And use this as a tool. Do you see? The obvious tool is that you can push it that way. So it means this is what the output is in here, and this is what is the input over here. So if this is the case, you have this equation that F is equal to B times X dot. So this corresponds to this block diagram. And you may say this is equivalent like this. And then you have the other one over here, which is the, if I draw it the other way in here, I have it like this. This is now F, this is in, and this is out. This is as if you have again your hand like this. Yeah. So in here you have the equation here is going to be that X dot in this case is equal to 1 over B times F. So this equation corresponds to this bond graph model, this equation to this, but also this corresponds to this block diagram. So this is what is equivalent. So that's the equivalency between block diagrams and bond graphs for the R element, in this case, a mechanical damper.